Hi, I'm Bill Hobson with Emerson Process Management Regulator Division. Today, we're going to do maintenance on the Fisher Type EZR elastomeric regulator. This regulator is very commonly found in the natural gas industry today. Before we do any maintenance, it's very important that we shut off the upstream pressure, the downstream pressure, and ensure that all pressure is bled out of that system. Once we've confirmed that, we can start our disassembly and inspection of the unit. I'm going to disconnect this tubing, and I've got a bleed line here I'm taking off. Also got down here a control line, and as you can see, both of these lines go downstream. And then over here is another line which goes to the upstream, and by taking this off first, it ensures that I have no pressure left in the system. From there, I'm going to go over and actually take off these bolts from the bonnet, and we will be able to pull the trim out of this regulator while leaving the body in line. So it makes it much more simpler and much quicker for us to do. Today, most companies install regulators and different types of valves that can be worked on in line without removing them. If we go back several years ago, a lot of the products had to be unbolted from the pipeline, taken out, and worked on, reassembled, and then put back in the pipeline. And a lot of times this required more than one person to do this maintenance, and occasionally it was very difficult to get that pipeline line back up again. As I open this regulator up, I like to make note of its function, its position. Was it a single cut? Was it a two-stage cut? Or maybe it was in a monitor situation. And was it the worker or the monitor itself? I'm going to lift off the bonnet assembly here, and you can see that the elastomeric part and the valve plug are still in this unit. From there, we're going to pull out the cage, and we'll inspect this as we do our maintenance check on it. We're going to remove the rest of the parts from this body. We have two O-rings in here that help us seal the unit up. First of all, the bonnet O-ring. Down in the body, we have a lower O-ring, and then the strainer basket. This strainer basket's purpose in there is to catch large particles coming through the flow stream, maybe like well slag or something of that nature. At this point, we've got all the parts out of the unit, and we're going to take those over to the bench and finish our disassembly and inspection. We're going to do our final tear down and inspection of the EZR parts that we've pulled out of the body at this time. In order to evaluate this, we need to consider a little bit the flow path in there so we can be able to determine how the flow is coming up through there and where it might wear our parts. If you recall, this basket was in the bottom of the body, and that's in there to catch some larger particles, well slag, and so forth. Flow from there goes up through the cage, and this is a unique cage. If you look down in here, you can see it's tapering in. We actually take some pressure drop in there before it gets up to the valve plug. If we pull this plug assembly out of the bonnet and put that on there, and if we look up the cage, we can see that all we see is that metal plug up there. We don't see any rubber part. So it takes the energy out of the particles when it hits that hardened stainless steel plug instead of the elastomer. The diaphragm itself is a very flexible part and has two purposes. The cage has a knife edge seat on it, so one purpose of this is to actually provide bubble tight shutoff, which we can get even with dirt or sulfur in the unit. The other purpose of the diaphragm is just to travel this plug assembly up and down and doesn't really deform our rubber very much. Flow is going to come up, hit this plug, and then go down through the cage. This is a whisper design, gives good noise attenuation because of the large expansion area in the body. Plug assembly itself goes up into a stainless guide bushing in the bonnet, so you always come back to that same position. If we take this cover off, we can see that this unit has a travel indicator in it. And in operation, we can tell if the unit is shut off, if it's open a little bit, or maybe it's wide open. We're going to inspect the cage, and this cage has a knife edge seat on it, which is very important for shutoff. We want to make sure that we don't have any nicks or anything in that. This is well protected. It's made out of a hardened stainless steel, so normally we wouldn't expect anything to be wrong with that cage. Pull our plug assembly out here and inspect this diaphragm. And what we're looking for is cuts, or maybe a little bitty hole starting to do that. If you kind of pull the rubber a little bit, if there's anything in there, you can usually see that. You'll notice that there's a ring around the center plug here. That's where the knife edge seat goes in. That's very customary for that to be that way. If this has been in very high pressures, you'll also see some indentations from the window, which doesn't hurt it either. We would like to take a look at the back side of this, make sure we're not getting any blistering or anything like that on the diaphragm. We determine that we need a new diaphragm on here. There's a little place in the back to put a screwdriver through. We take this nut off. With that, we're going to be able to pull this diaphragm off in the head. There's a couple O-rings in here. These O-rings actually give us the seal on the diaphragm so we don't over squeeze it. We put a new diaphragm in here, we put some new O-rings in. We're going to want to put a little bit of grease on those. Slide that down on there. Our top O-ring, give a little bit of grease on it. Slide it down on there. Next comes that valve plug, and then our nut. We're going to draw that back down. This is a machine tolerance in here, which goes metal to metal, so we can't over squeeze the elastomeric part. There's a torque value in the instruction manual. Generally, if you get that good and tight, you're going to be in great shape there. Before we put this back into the bonnet, there's an O-ring up here. We're going to want to put a little bit of grease on that. And also, we're going to put a little bit of grease around this outside bead of the diaphragm, both top and bottom. And this goes back into the regulator. That's going to be squeezed down over that cage. So we want that to be able to slide in there and not cut it. Another part we'd like to take a look at here is a restrictor. This cage is 100% capacity right now. If that's too large and I need to restrict that, there's two different plates, a 30 and a 60%. These plates drop right in the bottom of the cage and they're retained with a snap ring. So you can change the capacity without buying the expensive cage, only the restrictor plate. If we move over here to the filter and pilot, we take this filter bowl off. We can check in there for liquids and dirt buildup. Find out if we need to put in a new element or not. This is the element, and if it's fairly clean, you can put it back in. If it's got a lot of dirt and stuff built up in it, you're probably going to want to change that. There's a holder down in there and a holder up here in the top. Put a little bit of grease on this, threads, and screw that back on there. Pilot itself, this is a PRX. It's a double diaphragm pilot, and we're able to take this bottom cap off and check the seat in it without releasing our spring pressure. This is quite an advantage, so we don't have to reset the unit when we put it back on the flow line. The double diaphragm makes it balanced, so it's extremely accurate. And if we look at the side here, we're going to see that there's two different settings on it. One of them's a restrictor and one's a damper. Most of the elastomeric regulators have a restrictor with them, and that allows you to set the gain or set the accuracy of the unit. If you happen to have some instability, then you have to reduce the gain and reduce the accuracy of the thing. With the PRX, you can maintain that high restrictor setting, bring the damper down, which restricts flow from one diaphragm to the other, and take out instabilities. So it makes the regulator extremely stable on low flow conditions. Okay, once we get this cap off, we're going to be into the bottom here. There's a little bitty flat on the end of this stem. We're going to get a wrench on that. Then we're going to get a wrench on this. We're going to take that loose without turning that. Pull off of there. We'll pull the bottom diaphragm off. Really, this gives me an opportunity to look at that and see what condition it is in. If it's in good condition, I'm pretty comfortable that the upper one is in good condition, and I probably don't need to look at that. The seat is coming out next, and this is a disc that has urethane embedded all the way around it. The orifice in here is a little knife-edge seat, and you can see that that's offset to one side. So if I get a spot that's getting worn in the disc here, I can merely rotate that a little bit, and I'm ready to go again without buying any new part. Put that back on there. The diaphragm looks very good here. Wouldn't hurt to put a little bit of grease around that outside bead again. That slides in there well. Put that back in there. The diaphragm head has got some little serrations on it, which actually grip that diaphragm on the bottom. There's a lock washer. Then I put the nut back on there. It's important that I do hold that stem as I tighten this up so I don't allow that to turn and twist up my other diaphragm. At this point, check the O-ring on the bottom here. We'll put a little bit of grease on that. Grease we've been using on this here at the factory is a Lubriplate Mag 1. It's a general purpose grease. It's good down to minus 20 degrees Fahrenheit. So it works out very well in most of the applications. If we get into something colder than that, we'll probably go to a low temperature Teflon fill grease. So we're going to put this back on here. Draw these bolts up. We'll bring those down fairly even, so we're not trying to crush one side of the diaphragm or our O-ring. We're just about ready to put it back together. Okay, when we get over to the body, we've got two O-rings here, and first of all, we're going to put our strainer in there, and then we're going to put this O-ring in. We do want to grease this O-ring. And you might note the bevel on this cage is where that O-ring goes. Actually, this sets right up on top of the strainer, and that squeezes it out against the side of the body then and gives us a good tight shutoff on there. The other O-ring goes around the bonnet, and if you look at the bonnet, there's a bevel around that also. We're going to want to grease that O-ring up a little bit and drop it down in there before we draw that down. I think at this point we're ready to go back and put it into the body again. Before we put these parts in here, we want to make sure that this body doesn't have any foreign material or objects in it. We're going to go in there and wipe out any grease or dirt that may have built up in the body itself. We look clean in there. We're ready to finish our assembly here. First thing that goes in there is the strainer basket. If your EZR doesn't have a strainer, there's a shim in there that's about that same thickness that makes the stack height right. It's very important that you do not put the strainer and the shim in. You just require one of them. The O-ring is the next part, and we're going to put a little bit of grease on that. We use the same stuff that we used on the diaphragm before. We're going to lay that down in the body. Get it positioned in there properly. There we go. The next part that we need to put in is the cage. Just going to drop that right down into the body. Make sure it seats on that O-ring okay. Our top seal is this bonnet O-ring, and we're going to put a little bit of grease on that. Make sure it slides in position well. And drop that in there. Now we're ready to put the bonnet and plug assembly in there. And we're simply set that down in there. We're going to put our bolts in, and we want to make sure that we pull this bonnet down very evenly. If we bring one side down before the other side, we have an opportunity to crush that elastomeric part in there. We certainly don't want to do that because it will fail in. So we're going to make sure that we do draw that down very evenly. And we can actually just do that with a couple bolts before we put the others in. This bonnet assembly is going to go down. It's a metal to metal thing. So if you bring it down straight, you can't over torque it. Okay. We are pulled down there at this point, and we can go ahead and put the rest of our bolts in now and draw them down. After I get these remaining bolts put in and drawn down, I'm going to reconnect the tubing to the pilot over here and pressurize the system back up. I need to check for leaks around my tubing and joints that I've broken, and also want to check my set pressure, make sure that it's right on the set point that we desire out there. And I'm going to run a lockup test on this unit to verify my reassembly and what I've done to the regulator before we let this thing go and walk off. And that completes our reassembly.